Hi, my name's Liz Driscoll. I'm with North Carolina Cooperative Extension's 4-H Youth Development Program. I have one of my favorite curriculum, Soil Solutions. This is a 4-H school enrichment curriculum for third grade youth, and it is all about helping them understand the world of soils and plants and how the two of them work together to grow and make wonderful things. Today what I'm going to do is I'm going to show you a pour-through activity that is one of the early lessons on soils. So what you need is some simple tennis ball containers that have a hole drilled through the bottom, very fancy. You're going to have a piece of screen that you've cut and put in the bottom of the tennis ball container. And then what you need are 3 different types of soils. So in the curriculum, it encourages youth to begin to understand the landscape around them. So they might go on their school grounds or in their neighborhood and collect different types of soil, and they can use that soil, or you can use soil samples that you might just have lying around. So today I have a coarse sand, so sand that is really large soil particles. I have a loamy soil, and then I have a clay soil. Take a scoop and get about the same amount of soil in each of your different containers. So I'm going to get a little less than a cup and pour it in there. It helps if your soil is actually dry. The water will go through more like you would expect. If they have big chunks in them, see if you can get rid of some rocks and twigs and other things that might have collected. Kind of shake it a little bit so it's packed in there. If you have extra soil that comes through the bottom, just dump it out. And then my last sample is my clay sample. So a little secret, what I do for my clay soil is I'll collect it, I'll dry it, and then I'll put it in a blender so that it's all nice and ground, so it's easy to go into your pour-through container. If you're doing this, if the youth are doing this, be careful. Some of the soil particles will be a dust, and it can be an inhalation risk, so watch out for that. Now you have your 3 different soils right here, and you can begin to ask your youth a lot of different questions, like which soil do you think water will go through the fastest? Which will it go through the slowest? What do you think you'll see when the water goes into the soil profile? How long do you think it'll take? And then if you're using a measuring cup, you can have a measure and make predictions about how much water they think will actually move through the soil. So I have funnels just to make it a little bit easier for the water to go through and not run down the edges, because then it's not going through the soil, it's going through the edge of the container. And then I have 3 more containers, and I've filled them all up to about a cup. So this is where, if you're doing it as a demonstration, ask for some volunteers to come in and help you, but we're going to just try to do this as quickly as we can. So kind of gently pour it about the same rate, and then pour a little clay. We'll get caught up here in just a minute. And what I hope that you are seeing is that it went through the sand, the coarse sand, really quickly. And you can ask the students, well, why do you think that happened? Well, sand is so big and it has so much space in between it, it's really easy for the water to go through. In the loamy soil, they're little smaller size particles. The holes between the soil particles are a little tighter, so it takes water a little bit longer, and you can still see that there's a bit of water that hasn't infiltrated the surface of that soil that's still going through. But you can see a lot of it is starting to move through. And on the clay soil, even though we poured it a little bit late, no water has gone through at all. So this is hopefully what your youth might expect to see, is that clay with the tiniest soil particles would be the slowest for water to go through. And if you set this aside in just a couple of minutes, you'll start to see the water drain through. Once the water is all done draining through, you can measure it, and this says that it's about 2/3 of a cup, and we put in a full cup. So you can ask them, where do you think that water is? And it's actually in the soil right now. So this is a pour-through demonstration, really easy to do. This is a simple way to talk to kids about the different soil types, the relationship soil type has to water, and then how plants might grow in a soil that is a little drier or droughtier, like a sand, versus a soil that might stay saturated, like a clay soil. There's a couple of other really cool things you can do with this demonstration. You can talk about soil compaction. So if you take one of your soils and you take a giant dowel rod, you can actually have the kids compact the soil. So have them tamp down on the soil surface, and what they're doing is they're smushing all of those soil particles close together. And you can ask them, compared to when we just did the pour through, how long do you think it will take for water to go through this soil? So there's a couple differences. This soil is now wet. You could do it with dry soil. I'm going to move this one aside. And what you would expect to see is, because it's all smashed together, it's going to take a long time for that soil to infiltrate. So let's just see if we can observe this happening. All right, kind of very gently pour this through. And I see some water starting to go through, but if we compared it to the last one, a lot of that water is sitting right on top. And so that's one great way you can talk about why farmers don't go into wet fields, because a tractor might compact the soil and then water has a hard time getting to the plants. So you can use this for a compaction exercise. And one of my favorite activities is where you can do it and you can talk about one of soil's most important functions, which is that of a filter. So take your some new tennis ball containers and put your cups underneath. Grab a couple of more screens to set it up. Let's see, for this one we're going to use our loamy soil. So bring that bucket of soil over here. Grab about a cup of soil. And what I mean by when I say soil is a filter is soil can filter out different pollutants. Like say half of our country is on septic systems, so human waste is a pollutant, and so it filters out that. You can use soil to filter out other chemicals that might get in. And so the way it does that is soil has positive and negative charges. So what I have here is I have two different solutions. I have a negatively charged solution and I have a positively charged solution. And so what you would expect if our soil is usually negatively charged, not always, but most often. And so you can begin to talk about soil chemistry. And so if you pour a positively charged solution into a negatively charged soil, I wonder what color do you think the water will be when it comes through the bottom? So make a prediction in your mind right now. And I'm going to try to slowly pour this through. So watch for that. Then on this one, we have a negatively charged solution going through a negatively charged soil. Oh. All right, so what we're seeing is this soil is a little more coarse than I expected, but what you would typically see is that this solution would be a little more clear than it actually is. It is fairly purple. And on this one, you would see the color of the water to be about the same as what you poured through, because negative repels negative and positive will adhere to negatively charged particles. So this is a lot of how soil nutrients work too. So two very good demonstrations that you can use to show young people about the importance of soil as a filter. So this is above and beyond soil solutions, but lots of good ideas where you can literally dig into soil and find out a lot of good information. If you have any questions, please let me know. Liz Driscoll with North Carolina Cooperative Extension.